Good evening and welcome to today's lesson. Before us, we have mathematics, and the topic we are going to treat today is Pythagoras theorem. We must have heard of this theorem over time, but today we want to tell you how come do we use this theorem always, and the importance of it, and possibly the application of the theorem. The Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the square of the opposite and the adjacent. Inside this figure you are seeing here, we have different shapes here. In the middle, ABC, figure ABC is a right angle triangle. Take note, Pythagoras theorem is only applicable to a right angle triangle, not any triangle. You can have this. This is a triangle, but not a right angle triangle. What is a right angle triangle? A right angle triangle is an angle that has 90 degrees as one of each angle. Like here now, this part is a right angle triangle, and this part too is also a right angle triangle. You can see figure ABC is a right angle triangle because it has what? A 90-degree inside of it. We have other angle. This place too is an angle. This place is an angle, but that is not the topic of discussion today. The theorem states that the square of the hypotenuse, you can see the hypotenuse here, you can see I have a square here, is equal to the sum of the square of the adjacent and opposite. What is opposite? Opposite is the side that face the angle if any angle is included. For example, I have this as my angle. That means this side becomes my opposite. But if I have this as my angle, this side becomes my opposite, and the other side becomes the adjacent automatically. But one thing that do not change is the hypotenuse. That is the side that faces 90 degrees. So in mathematical terms, what this theory is saying is that this shape, this side, which is the square of the hypotenuse, is equal to the addition of the square of this, and this is a square. BCDE is a square. AHIC is also a square. Mathematically, we have A, this side AB, the square of side AB equals to what? The square of side AC plus the square of side BC. Strictly hypotenuse. For example, when you are given a question like this, no angle is included, and you have maybe 5 here, you have possibly 3 here, and you have 4 here. Well, in this case, we know all the sides now. But what if you don't know this side and we need to calculate that side? Okay, let's look at it. We want to calculate this side. What does the law say? It says that the square of the hypotenuse, this is the hypotenuse, the longest side. Don't forget we have 90 degrees here. Square of the hypotenuse is equal to the sum of what? The square of what? Opposite and the what? Adjacent. In this case, knowing the adjacent, we just have to choose any side because we don't include any angle apart from the 90 degrees here. In this case, we can simplify further. The square of 5 is 25, and the square of 3 is 9, and we have this, the unknown we are looking for. In this case, what do? You subtract 9 from both sides. In this case, we are going to have 25 minus 9 equal to what? X squared. Then we have 16 equal to x squared. In this case, what we do? We find the square root of both sides in order to remove this square. What we want is x, not x squared. In this case, we have what? X square root of 16 equal to square root of what? X squared. So this, we cancel this, and we have 4 as well, the square root of x. Therefore, our x equal to what? 4. Mind you, some students usually make this mistake of saying x squared equal to 5 squared plus 3 squared. as far as they are asking them for x. No, it is strictly, this is very wrong. It is strictly what? The square of the hypotenuse that is equal to the square of the opposite and the adjacent. Thank you and welcome once again.